Hi, I'm Matt, and in this video we're going to go over the factors that affect the rate a reaction proceeds at. This is very important in industry because sometimes we want a reaction to go faster so we can make more of the material, or in science we want a reaction to go slower so we could better study it. Now, before we could go over how to speed up and slow down a reaction, it's important to know what causes the reaction to occur in the first place. So the first thing that causes a reaction to occur is proper orientation. In other words, the particles must collide in such a way that an atom can transfer from one molecule to another. For example, let's look at the reaction between carbon monoxide, CO, and oxygen, O2. On the top, we see that the oxygen in carbon monoxide and one of the oxygens in O2 are colliding. This will not cause a reaction because the oxygen cannot go to the carbon that it's supposed to bond to, while on the bottom of the screen, it can transfer because the oxygen directly touches the carbon and the carbon is able to hold on to the oxygen, splitting up the O2, leaving us with our products of CO2 and one oxygen atom. The other factor needed for a reaction to occur is that there has to be proper energy in the reaction. In other words, for the reaction to occur, the particles must collide with enough energy for the molecules to react. We call this minimum amount of energy for the reaction to occur the activation energy of the reaction. Now, at this point I understand it may be a little difficult to understand the idea of activation energy, but hopefully the next example will clear it up a little. So I like to imagine activation energy using a smartphone because it's much bigger than a tiny little particle. And let's say that the activation energy is the energy needed to crack the screen. So let's say you toss your phone onto your bed, you're just regularly using it. It's hopefully not going to crack because you're not putting a lot of energy into it. But then, let's say you're walking on the sidewalk with your friends and you drop it onto the pavement. Now it cracks. That's because the amount of energy needed for it to crack has been exceeded. It's the exact same thing with particles. After a certain amount of energy has been put into it, bonds will break and reform differently. So here we see that cracks are how it forms differently, while on the particulate level, we would get two different substances. Now that we've gone over what's necessary for a reaction to occur, we could go over the factors that affect the reaction rate. Overall, anything that will increase the collisions or increase the energy of the collisions will increase the rate of the reaction. So, there are 5 main factors that we're going to discuss in this video. The first one is temperature, the second one is surface area, the third one is concentration, the fourth one is catalyst, and the last one is pressure and volume. This only affects the reaction rate if one of the reactants is a gas. Firstly, we're going to discuss temperature. So remember that temperature is the average kinetic energy of a molecule. Therefore, at higher temperatures, particles have more energy, and at lower temperatures, particles have less energy. Therefore, at higher temperatures, the reaction will proceed faster because more collisions will have the required activation energy, because the particles themselves are more energetic, so when they collide, their collisions will be more energetic. The reverse would be true for cold temperatures. At lower temperatures, the particles have very little energy, so when they collide, the collisions are very unenergetic. Therefore, very few collisions will exceed the activation energy. Next up, let's discuss surface area. So you may be curious why I have a picture of an apple on the screen. That's because apples represent exactly what particles do during reactions. So, if you leave a whole apple in your fridge or on a counter, the inside may get brown, but it will probably take a while. Even if you cut it in half, it will take a while for it to turn brown. But if we were to cut the apple into many slices, as seen on the right, and leave it on a counter, we would get the brown pretty quickly because there's more surface area for the air to react with the apple with. Particles will do the exact same thing. To reiterate that, By increasing the surface area, there are more places for the particles to react, so collisions will occur more on that one particle, as well as the particles can spread out more in the solution when there's multiple pieces, allowing for more overall collisions. Therefore, when we increase the surface area, we increase the reaction rate, and when we decrease the surface area, we decrease the reaction rate. The third thing we're going to discuss is concentration. So a good way to think about concentration is to think of a parking lot. If we look at parking lot A on the left, there's very few cars, so could they collide? Yes, but it's not very likely. While parking lot B on the right is a lot more crowded. So collisions will occur much more frequently because there's not as much places for the cars or particles to go without hitting each other. So just like cars, the same applies to particles. If there are more particles or molecules in a solution, there will be more collisions because there's less places for the molecules to go without bumping into one another. Therefore, increasing the concentration increases the reaction rate, and decreasing the concentration decreases the reaction rate. The fourth thing we're going to discuss is a catalyst. A catalyst is any substance that could be added to a reaction mixture to lower the activation energy of the reaction. Since the activation energy is lower, more collisions have the energy needed to react because it's easier to achieve that energy. So overall, the addition of a catalyst speeds up the reaction. Now, it's important to note that the catalyst itself does not get used up in the reaction. So for example, if we use Cl2 or chlorine to speed up the reaction, after the reaction occurs, we should end up with our products as well as that chlorine. The last factor we're going to talk about is pressure or volume. Now, it's important to remember that changing the pressure and volume only affects the reaction rate if there are gaseous reactants. Because the reason pressure or volume affects the reaction rate is because at high pressures and low volumes, the particles are pushed close together and will hit each other more often. When it comes to solids or liquids, their particles won't get closer together or farther apart by changing one of these factors. Therefore, they would be unaffected. Next, it's important to remember that pressure and volume are inversely related. So if we decrease the volume, we increase the pressure, and if we increase the volume, we decrease the pressure, assuming that temperature is held constant. So at low volumes and high pressures, the molecules are very close, so there will be a lot of collisions with each other. While if we're at a very high volume and a low pressure, the molecules are far apart and will seldom collide with each other. Since the more collisions increases the reaction rate, when we decrease the volume and increase the pressure, the reaction will speed up. And if we increase the volume and decrease the pressure, the reaction rate would slow down. So here is visually what we were discussing on the last slide. On the left, we see that we have a very high volume and low pressure, so the particles are spread apart. While on the right, we could see that when the volume's smaller, the particles have to end up closer together, meaning they would collide more often. Now that we've gone over what's needed for a reaction to occur and how we could change the speed at which it occurs, here are 6 practice questions for you to review with. Question 1 is, what are the 2 things needed for a reaction to occur? Question 2, what is the special name given to the energy required for a reaction to occur? Question 3, what are the 4 factors that affects the reaction rate of all reactions? And which factor will only affect gases? How will decreasing the volume affect the reaction rate, assuming that there are gaseous reactants? What can be added to lower the activation energy of a reaction? And question 6, will an unbroken tablet or a broken tablet of Alka-Seltzer react faster? At this time, I encourage you to pause the video and try the questions on your own. The answers will be provided for you on the next slide. The answers are as follows. For a reaction to occur, there must be proper energy and proper orientation of molecules. The special name given to the energy needed for a reaction to occur is the activation energy. The 4 factors that affect the rate of reaction of all reactions is temperature, surface area, concentration, and the addition of a catalyst. Pressure and volume is the factor that only affects gases. If we lower the volume or decrease it, we increase the reaction rate. We could add a catalyst to lower the activation energy, and the broken tablet would react faster because there is more surface area. If you have any questions, feel free to leave them in the comments below. Thank you for watching. Have a nice day.